Hello everyone, welcome to today's lesson. My name is Sihle Mgaga. Today we'll be looking at the nature of roots, which forms part of your question 1. Then before we get into the sums which involve the nature of roots, we'll have to firstly look at a tree diagram that will somehow summarize the topic on its own, the nature of roots. Then what we have to remember before we go into the tree diagram, what we have to remember is that our nature of roots specifically deals with delta, of which our delta, it's this that we find on our quadratic formula. So the b squared minus 4ac, of which I can just write this in this form, it's a plus or minus. Then I put my delta here, all over 2a, meaning that my delta is actually equals to a b squared minus 4ac. So, with us having understood that our delta is b squared minus 4ac, we can then go to our diagram that summarizes what you are dealing with, the nature of roots. So firstly, we'll take our delta, and then now we go to say if our delta is greater or equals to 0. If I do my calculation and find my delta being greater or equals to 0, I'll have to conclude by saying the roots are real. Then if I calculate and find my delta to be less than 0, when I comment now, I'll say my roots are non-real. So the questions you'll find, they'll be saying to you, they'll give you an equation, and then the instruction is discuss the nature of a root. Then you'll have to find your delta. Then after finding your delta, if it's greater or equals to 0, your comment will be the roots are real. If you find your delta being less than 0, your comment will be non-real. Then when it comes to real, it continues further to branch again into your delta. Now we just separate these. My delta is now greater than 0, or my delta is equals to 0. So if I find my delta being greater than 0, my comment will be the roots are unequal. Then if I find my delta to be equals to a 0, I'll say my roots are equal. Then it goes further on this side where your roots are greater than 0, which your comment is unequal. It goes further to of which now from here we'll have our delta being a perfect square. If you remember, we are from sets where we discuss what's a perfect square. Then we find our delta being a perfect square. When your delta is a perfect square, you'll have to comment by saying your roots are rational. Then if you find your delta not a perfect square, not being a perfect square, you'll have to comment by saying your roots are irrational. So this is like the summary of what you'll be dealing with when we do the equations that are in relation to the nature of roots. So when it comes to this side of your delta being less than 0 and you saying your comment is your roots will be non-real, this one, it has no continuation, it will just end there. But whenever you find your delta to be greater or equals to 0, your first comment is to be real. Then from there, you'll check between the two. Is your delta greater than 0? If it's greater than 0, your next comment will be unequal. If your delta is equals to a 0, your next comment will be equal. But once your delta is equal, then it ends there. You can't continue any further. But if you have found your delta to be greater than 0, then you commented by unequal. Once it's unequal, it will either be a perfect square or not a perfect square. But if it's a perfect square, your next comment will have to be rational. If the delta you found is not a perfect square, your next comment will have to be irrational. We are now on our first sum under nature of roots. And the instruction is to discuss the nature of the roots of x squared minus 7x plus 10 equals to a 0. So, for you to answer the question, you firstly have to find your delta, of which delta is given by the formula is delta equals to b squared minus 4ac. Then delta is equals to a b squared. My b is a negative 7 squared minus 4. My a, it's a 1. We take this one from the coefficient of x squared. Then c is a 10. Then from here, we go for our 7 times 7, which is a 49. Then we go for our negative 4 times 1, or you can just go for a negative 4. Then you say 1 times this, it's a 10. Then now your delta is to be equals to a 49 minus 40. Then your delta is equals to a 9. Now that we are done, you've found your delta. You can then refer to the table, the one we drew, where our delta is either it will be greater or equals to 0 or delta being less than 0. But in this instance, for our sum, our delta is equals to a 9. So a delta being equals to a 9, it's my delta being greater or equals to a 0. It's greater than 0 or equals to a 0. So my first comment, I'll use this one, which will mean roots are real, comma. Then I still check my delta. My delta is equals to a 9. So my delta after real is not equals to a 0. It is delta greater than a 0. Since it's greater than a 0, then I'll use the comment below, which is unequal. Then, lastly, under unequal, there's a continuation. Whether your delta is a perfect square or your delta is not a perfect square. So in this instance, a 9, when you take a 9, this 9, you take your delta under the root, of which my delta in this instance is a 9. I take it under the root, it's a 9. I'll get a 3. For a root of 9, it's a 3. So 9 is a perfect square. So then, my delta being a perfect square, the last comment will have to be rational. So they are real, unequal, and rational. So, with this, I've concluded. I'm done. Since the instruction was to discuss the nature of the roots, you firstly find your delta using the formula, substitute, then also find your delta. Then you take your delta, you'll then refer to your diagram to write these comments that you wrote here, which is real, unequal, and rational. We are now on our second sum. The instruction is still the same. Discuss the nature of the roots of x squared minus 11x plus 18 is equals to a 0. So we have to firstly find our delta using the formula b squared minus 4ac. Then our delta is equals to our b is a negative 11 squared minus 4. My a is a 1, c 18. Delta being equals to negative 11 squared, it gives you 121 minus a 4 times 1 times 18 is still 18. Then my delta is equals to 121 minus 72. Our delta being a 49. So after having found your delta being a 49, you'll then go to our diagram for reference, of which you must remember that this diagram, you won't find it on your formula sheet. This is supposed to be something that you learn and you know. It won't be part of your formula sheet. Therefore, let's go back to the sum. My delta is a 49. Then I go on to check. Is my delta greater or equals to 0, or is my delta less than 0? So I find that my delta is a 49, meaning that my delta is greater than a 0. So I'll use the comment below, which means that my roots, first comment, they are real. Then, when my delta is real, it goes further to show that delta being greater than 0 or delta being equals to a 0. In this instance, my delta is a 49, meaning that my delta is greater than a 0. So I'll use the comment below, which is unequal. Unequal. Then, lastly, under unequal, it's either you'll have delta being a perfect square or you'll have a delta not a perfect square. So we go on to check that my delta, I got my delta being a 49. Then I take my delta under the root, which is now my delta it's a 49. And the square root of a 49, it's a 7. So my delta is a perfect square. So delta being a perfect square, the comment you'd use is a rational. So, and last comment, rational. So for this equation, discuss the nature of the roots of x squared minus 11x plus 18 is equals to a 0. You find your delta being a 49. First comment is real, comma, unequal, and rational. Then, yeah, we are done with the second sum. Our third sum, same instruction. Discuss the nature of the roots of x squared plus 2x plus 5 equals to a 0. Then we'll have to find our delta using the formula b squared minus 4ac. Our delta being my b is a 2 squared minus 4. My a it's a 1. Then my c it's a 5. Then from here we continue to say 2 squared is a 4 minus a 4 times a 5. So my delta being equals to a 4 minus 20. Then my delta being equals to a negative 16. Now that we have found our delta being a negative 16, we can then refer to our diagram here. We check, first step, is my delta greater or equals to 0, or is my delta less than a 0? So I found that my delta is a negative 16, meaning that my delta is less than a 0. And when your delta is less than a 0, there's only one comment where you'll say the roots are non-real. And when your roots are non-real, there's no continuation. So that's the only comment you leave, that the roots are non-real. We're now on our fourth sum. Instruction is still the same. Discuss the nature of the roots of 3x squared minus t, open bracket, 2x minus t, close the bracket, is equals to a 2, open bracket, 2x minus 1, close brackets. So for such a sum like this, we have to apply the Bodmer's rule, where we are to remove these brackets by multiplying out. So you go to 3x squared, you multiply negative t times a 2x, you get that it's a negative 2, then tx. Negative t times negative t, you get a plus t squared equals to 2 times 2x, you get a 4x. 2 times a negative 1, it's a negative 2. So from here, we'll take these to the other side. So 3x squared minus 2tx plus a t squared minus 4x plus a 2 equals to a 0. Now we check for the like terms if we have, but there are no like terms. From here, we go to our equation, this equation, which is y, okay, let's just go for an ax squared plus bx plus a c. So everything before x squared will fall under a, everything before x will fall under b, then everything else that remain, we treat it as our constant. So we go back to our sum to check. Everything before x squared, it's our a. How many? We only have a 3, which is before x squared. So let's just go for our a in the formula. We'll have a 3. Then for our b, of which our b refers to everything that will be before x. So now, before x, we'll have negative 2x, negative 2t, negative 2t. What else is before x? We have our minus 4. Then, is there anything else that is before x? We don't have. Then you go for c. The t squared is not before x squared and is not before x. So for c, we'll have a t squared, also a plus 2. So now, we can go to our formula. Since the instruction is to discuss the nature of a root, we can go to our formula, which is delta is b squared minus 4 ac. So our delta is a b squared. In minus 2t minus 4, it's our b minus 2t minus 4 squared minus a 4. For our a, we'll substitute a 3. For our c, we'll substitute a t squared plus a 2. Then from here, we are gonna multiply out. So our delta is equals to the same bracket twice, of which is a negative 2t minus a 4, negative 2t minus a 4. Then from here, we multiply out, can multiply out these two. A minus 4 times a 3, you get a negative 12. Then negative 12 will have to multiply out a t squared plus a 2. Then we're going to multiply out this bracket, of which this is to give us a negative 2 times a negative 2. Using the FOIL method, you'll get a 4 t squared. You multiply negative 2t times a negative 4, you'll get a plus 8t. Same goes, a negative 4 times a negative 2t, you'll get a plus 8t. Then you multiply a 4 times 4, you get a 16. Then you multiply a negative 12 times t squared, you get a negative 12 t squared. A negative 12 times 2, you get a negative 24. Then you go on to look for the like terms, which is the 4t squared and the 12, 4t squared and then minus 12 squared. These two will give you a negative 8 t squared. Then the other like terms that you have, it's a 8t plus 8t, you get a plus 16t. Then the other like terms that you have a 16 minus a 24, you get a negative 8. So from here, you can then take out a common factor. So your delta, it's, when I take out the common factor we have is a common factor of a negative 8. When I take out a negative 8, here I'll remain with a t squared. I take out a negative 8, here I'll remain with a plus a minus 2t, a minus 2t. When I take out a negative 8 here, I'll remain with a plus 1. So from here, you can take it further, which is a negative 8. Then you open two brackets. You get a t, you factorize this. T, 1, 1. It's a negative. So my delta, it's now a negative 8. Same bracket twice, minus 1 squared. So my delta is equals to a negative 8 t minus 1 squared. Then I'm done finding my delta. I then have to go on to comment. So given such a sum, when you are to comment, you'll still check on your diagram. But before you check on your diagram, you have to analyze this, what you found. You found your delta to be equals to a negative 8 with t plus 1 squared. So when we go for algebra, we remember that everything squared, you'll get a positive. Everything squared, you'll get a positive. Secondly, everything squared, it gives you a perfect square. So, for example, if I go on for a negative 3 being squared, I'll surely get a positive, which is a negative 3, which this gives me a 9. So, second thing, everything squared is a positive. Also, everything squared, a 2 squared, it means that it's what? A 2 times a 2, which gives me a 4. Then that 4 you get, remember, if you were to put it to a root, you'll get that root of 4, it's a 2. As much as if you were to take 9 under the root, this 9, you'll find that the root of 9 is a 3. So actually, everything squared is a positive. Secondly, whenever you're squaring the same thing, you're actually producing what? A perfect square. It was the same thing squared, we got a 9, which is a perfect square. Same thing, 2 squared, we got a 4, which is a perfect square. So now, we conclude that this will surely give me a positive. But this giving me a positive, I still have to multiply it out with a negative, which will make my delta to be negative. I'll have a positive multiplied by this negative, which will then make my delta to be negative. So now, my delta will be negative. I go to my diagram. to refer. The delta I found is not greater than or equals to 0. My delta will be less than a 0, which will make these to be non-real, based on those reasons I just gave, that this will surely give me a positive, but that positive I'll have to multiply with this negative, which will make whatever product I find here will be negative. So my delta will be less than 0. Therefore, even if you concluded by saying delta, even if before you conclude with even if you went on to say, therefore, delta will be less than 0 because of this, then you go on to say, roots are non-real. It's still acceptable. Which the instruction is, show that the roots of this equation are rational for k is an element of real numbers. We've underlined rational, for rational is like our keyword of what is expected of us as we solve this equation. So for your roots to be rational, it means that you'll have to find your delta being greater than 0. So now we are to show that the equation, the given equation, will give us a delta that is greater than a 0. Then we'll conclude that our delta is rational. Then when our delta is a perfect square, it makes it the nature of roots to be rational. So going back to our sum, we know that at the end we are trying to prove that delta is greater than 0. So now let's take our equation, x squared plus 2x minus 15 equals to a k, x minus a 3, then x squared plus a 2x minus 15 is equals to k times x, we get kx, k times a negative 3 is a negative 3k. Then from here we are to take these to the other side, so I get an x squared plus 2x minus 15. Take this to the other side, we get a negative kx plus 3k equals to a 0. Then from here we must check if there are any like terms, of which we don't have any like terms. So we'll then go to our delta. Before we go to our delta, we must put things into order, where on our a is everything before x squared. We only have one x squared, so there's a 1 before x squared. Then we go for our b, of which our b is everything before x. We have 2, we have a negative k, so we'll have a 2 minus k. Then we go for our c. For our c, we have a 3k and then negative 15. So 3k minus 15. Then from here, we can then go on to find our delta being a b squared minus 4 AC. Then our delta, it's a B, which is 2 minus K. It's 2 minus K squared minus 4. My A, it's a 1. My C, it's a 3K minus 15. Then delta is equals to the same bracket twice, which is a 2 minus K, 2 minus K, minus a 4 into 3K minus 15. Then we go on to do our FOIL method here, which is delta is equals to a 2 times 2, it's a 4, 2 times a negative K, it's a minus 2K, a negative K times 2, minus 2K, K times K, it's a K squared, 4, negative 4 times a 3K, we get a negative 12K, a negative 4 times negative 15, it's a 60 plus 60. Then we go on to collect the like terms, of which K squared is only K squared. There's no like term. Then you go for these ones, the ones with K. We will get a negative 4K minus 12. It's a negative 16K, then a 4 and a 60. You add them, you get a plus 64. Then from here, we'll then have to factorize. We'll then have to factorize, and we find that our factors go for K and K, and our factors are 8 times 8, then the sign is the same, negative and negative, which my delta is K minus 8 squared, same bracket twice. Therefore, the instruction was to show that the roots of this given equation are rational. When they are rational, it means that I must find, we said rational comes from delta being a perfect square. Then we explained on our fourth sum that everything squared will give us a positive. We also went further to say everything squared, meaning that the same thing multiplies itself twice, which then is taking us to what? To a perfect square. As we went for an example, we can do another one now to say everything squared. This will give us a 5 times a 5, which this is a 25. then everything squared will give us a positive. Even if this was a -5, -5 squared, so we still want to get a -5 times a -5, which this will give us a 25. So everything squared, whether positive or negative, you get a positive. Then our second explanation was, when you take what the product you got from multiplying what was squared, you put it under the root, you'll get a 5, meaning that everything squared will give us a positive, and the product of that thing that was being squared is now your what? A perfect square. Because a 25, a root of 25, it's a 5, making this 25 to be a perfect square. So now we have this being squared, which is going to give us a positive product. And that positive product will give us what? A perfect square. Therefore, I conclude delta, my delta is a perfect square. A perfect square. Which means roots are rational. Roots are rational. Yeah, we are done with the sum.